Today we started, so you have a Google Class, no, not Google Classroom, not added to, right? I don't have that. We have our own platform on Moodle that I will share with you. That's not everybody in the group, which it should be by today or tomorrow. I'm going to get your email and add you in, right? All right, David? And remember to please use it, right? And I'll be able to see when you're not using it. And I'll prepare. All right. So we went through this here last week. We started to look at some of the algebra propositions, right? We'll come back and look at those just now again, right? We talked about negation and all those things. Talked about negation, conjunction, and disjunction. Stop there. I thought that we stopped, right? One thing I want to point out here, which I did tell you last week, but I just want to point out one thing, right? Sometimes instead of being able to use truth tables and truth values only, we're going to have it in a worded case, right? For example, right. So if you look here, right? If you look here, negation, right? If you look at negation in a worded case, right? Negation, we use it to not. Right? So for example, if they said Q is rain is falling, let's say, then the negation of Q will be rain is, right? It will be rain is not falling. That's okay. So sometimes you're going to not use truth tables, but you're going to use the actual worded versions to explain it, right? Remember, conjunction is what? What's the word to represent conjunction? And what's the word to represent disjunction? Or, okay? So if you have to connect two statements with disjunction, you're going to use the or. What about this symbol here, the arrow? The word is implies. Okay? So for example, you would say P implies Q. All right? So I wanted to make sure you remember that, right? Today, and I gave you one more that's missing here. What was that? I gave you one more connective last week. After conditional, what was it? Right. Right conditional. And the worded version for right conditional was if and only if. Right? Sometimes we write it like that. IFF. If and only if. Right. We have three new things to look at. Contrapositive, converse, inverse. Right? Well simple, right? Let's start with contrapositive. Contrapositive, switch them around and negate them. Right? Converse, just switch them around. And inverse, negate them. Right? So if I gave you P implies Q and I said, what is the inverse of P implies Q? All you have to do is negate P and negate Q. That's the inverse of this statement here. Okay with that? Yeah? Yeah. Converse of this statement here, that should be a Q. Converse of that statement, there is a switch around Q and P. Contrapositive is the inverse and converse, right? Switch them around and negate them. Okay with that? Switch them around and negate them. Right? Just make a little note of that, please. Make a little note of what is contrapositive, what is converse, what is inverse. Right. Ready? Right, so I want you to try one here from the face. I want you to find converse, inverse, contrapositive of negation of Q implied P. Right? Find contrapositive, converse, and inverse of that from the face. Each one. Wait, you finish? Right, so what's contrapositive? The negation right, so what's here? First thing, we could try the converse. Right, this is better order to do them in, right? Right, converse of this, switch them around, so it's P implies negation of Q. Inverse, leave it as it is, but double negate. So negation of Q, negation of P. So we'll end up with Q implies the negation of P. Is that okay with that? Yeah. Contrapositive is the take the inverse and sorry, switch them around and negate them, right? So we'll end up with what? What we'll get here? What we get for the contrapositive again? Negation of P implies, right? Switch them around and then negate them, right? Remember this rule, right? Double negation cancel off, right? Okay. So converse, switch them around. Inverse, leave them as they are and double and negate both, right? And contrapositive, flip them around and then negate. Are you okay with that? Easy, right? Let's just quick pass this one. Any questions online? Let's see now. I'm not sure why it's not showing up. I'm gonna try it with the Nothing other. Try that quick 2019, which real easy. Part one, eh? Part one. I think we did part two already. Yes, part one. Say the inverse and contrapositive of P implies Q. Right? Q implies P is what? The inverse is what? Q implies P, and the contrapositive is negation of Q implies negation P. Will you okay with that? Maria? You okay with that? Covered? You okay with that, right? Right, there's a next one, though, that's words. Any questions online? David, are you okay?
Yes, sir.
Ariane, are you okay? Right, and Shabi, you'll see the one on top. One on top alone. This here, right? Ignore the rest. Alone and join that soon. Right, look at the one on top there. So yeah, let's think about how we're going to show that. Okay. I'll read it here, right? Faith? P and Q are two given propositions, right? Say the converse. Right, but here's the problem. Part two says, show that the contrapositive of the inverse P implies Q is converse of P implies. I don't know. Very good. Truth tables, right? So you have to set up a truth table and show that all the truth values that you see. Very good. Right, set up is I take your time and do the truth table. I'll show you that now. Huh? Yeah, in order for us to show it. So let me see, right? Understand? Sorry. I'll do it right again. Tell me now. Right. So the inverse is negation of P negation of Q, and the contrapositive of this is negation of Q implies negation of P. What is that? The converse of? Right. Show the, what's the question, right? Show the contrapositive of the inverse. Oh, okay, yeah. Show that the contrapositive of the inverse is converse, right? Okay, yeah, that's what I said. So we don't need a truth table to show that really. Right? So they gave us P implies Q, and they said show that the contrapositive of the inverse is the converse. Oh, sorry. Right? So before we do that, we could write down what the converse is. What's the converse of this? So it will be Q implies P. So they want us to show now that the contrapositive of the inverse of P implies Q. Right, sorry about that. There's the next one, just like this, where you have the truth table, right? Right, there's no need to do the truth table because this will be exactly like this. So it doesn't make sense to go back and truth table. So contrapositive of the inverse of P implies Q. This is the inverse of P implies Q. So it's negation of P implies negation of Q. So therefore, the contrapositive of this is the negation. Remember, switch them around and negate it. So you'll be left with Q implies P, which is the did I write it? Yes. Which is the converse of P implies Q. All right. So it's more like a direct proof that we have to show. Okay. So contrapositive of the inverse of this, right? And the inverse of this is this. And the contrapositive of this, switch it around and negate it. Right? There was a direct proof. Right? Yeah, no, there's a next question that asks you to show that I think it was to show that this and one of them logically equivalent. Online, are you okay with that? So based on the worded question, they wanted the contrapositive of the inverse. And the inverse was this. So they want the contrapositive of this, so we switch it around and negate. Right? And we were able to show that this is the converse of PM plus Q. All right? So it's more like a direct proof that they want. Right? So the algebra questions all well and nice when they come like this. Right? Sometimes they ask you, well, to be honest, it never came before, except it came on the specimen paper once, where they ask you to prove something using the algebra propositions. All the other years, they have asked you to use it using truth tables. All right. So you see, like how we prove logically equivalent, again, the truth table. Yeah. Now, sometimes we can prove it using algebra propositions. So I'm going to give you the list of all the algebra. Remember last week I was showing you how to get them? Right? I'm going to give you the list of the algebra proposition. And we just going to try to move on that. Right? It never came before, but I just going to give you one of the practice, right? So let's take a look at algebra. Next heading, algebra proposition. Oh wait, I have two more definitions before I give you all. Right? We have two more definitions to remember: tautology and contradiction. Right? We have done it already. Tautology is when the entire column is true. Contradiction is when the entire column is all the true values is false, right? Let's make a note of that now before I'll give you all the rules there. A tautology is when all the truth values are true. Contradiction, other way around, right? Right? A tautology occurs when everything is true and the contradiction all is false, right? So before we do any questions on the algebra, I'll just give you back all the rules. As I said, it never came before, but it's on your syllabus. And you don't really close here to get this. I know it. All right. So let's start here. All right. You got the quality handwriting. Got the quality handwriting. Am I good? All right. So here are some of the algebra propositions. You don't have to memorize the laws, right? Just make sure you can apply them, right? So remember I showed you this last week. P and P will always be P. P or P will always be P. Copy down the laws. To the right there, those are the names of the laws, right? To the right is the name of the laws, right? Copy down the laws. And then we go down and try them, right? Right, so I tried to show you last week how to come up with some of them, right? Like P and true. So P or false down for P, right? I showed you if you remember your truth table, how to come up with that. Right? Next set of rules. Next set of rules here. Good job. So good. Next set of rules there, right? Right in on that. I give you all that word. It's a method. It's a gentleman. I here to do, yeah, yes, screenshot. Take a picture of it. This one, this one. Take a picture of it, picture. Right? And we're going to try to apply those rules now. You will apply it. Right. Alright, so how do we use all these rules here, right? Right, how do we use all these rules? Huh? I'll give it to you, I mean, you want it, you want it. Right? Why you're definitely up to it. Right, some of them easy, right? Like for example, let me just point out the ones that easy. 1, 2, 3, 4, 5, 6. Right, those come straight from linear gates. Right, unit disjunction and conjunction, commutative, simple. Are you okay with that? Commutative laws. Right, the associative laws, basically you just put in brackets at different points. That's all. Right? The one that's new is the distributive law. All right, look at the distributive law. The distributive law is like if you expand it out, right? I'm going to see if I can show you here. Watch this here, right? Let's say I have P. Let's see that. Let's say I had P or Q and R. Right? It's like expanding out, right? Let's see. Right? Watch this here. Suppose you had P or Q and R. It's like kind of like multiplying it out. So it will be P or Q. So you're multiplying this by this. You're multiplying this by this. Right? And then what goes in the middle? And. That's okay? So you're multiplying this by Q, this by R, and then the and goes in the middle. That's it. Why I can't work? Inside here first. So what you do here? Right, because inside the bracket you really have anything else. Here now, to go from here to here, it's like factorization. You're factoring out P and you're factoring out the four they have in common, and then you have Q and R. Right? That's how we kind of remember it. Yeah. You okay with that? Right? And then there's one more law. If I were to negate P or Q, right? I'll negate P, negate or negate Q. That's okay? So this is the more ones, right? But you definitely names for now. But I want you, when you see this, you can go here, or when you see this, you can go here. Right? Or if you expand this, you'll get this. That's okay? All right? So let's take a look at some examples on it. As I said, it never came before, but it's on the syllabus. Right? We have some, right? Right, so let's prove right. So what's one way we can prove this? What's one way we can prove this? Besides the algebra, we can use truth tables, right? So we can show that, develop a truth table and show that the truth values for these two are the same. Right? But if they told us to use algebra propositions, right? That's where we have to use those rules that I showed you. Okay? Which side you'll look at? Left or right? Left has more info, right? So let's start with the left side. Right? P or Q and the negation of P. This is not looking familiar, so I just want to switch them around, right? So I will use commutative law and switch them around. What is looking like now? Distributive. Well, that's showing you. So can I multiply this out? So I will end up with negation of P and P. Negation of P and Q. So this by this, and then the O in the middle. So okay with that? Wait, what's this here? What's the negation of P and Q? Try to remember, and these are two opposite things, and whenever they opposite, what you'll get? Well, false. That one. Oh. Right? So negation of P and P, look at your rules. Negation of P and P is false. Right? Now you have false or anything. Look at your rules. Look at your rules and tell me what's false or anything. Anything. And what is false or P? P, right? So this whole thing here, P. So false or anything is the anything. Are you okay with that? And this is the same as this. So you know. That's okay. So it's simple once you know your rules. Are you okay with that? Copy down. Let's go again. I'm not giving you much because it's won't give you trouble. Online, are you okay there? Right, so the first thing I did, I just switched them around so I could apply the distributive law. When I applied the distributive law, right, I went on the, right, I went and I looked for negation of P and P and I found it's false. And we know that false for anything else. Anything. Okay. You have to look back at your rules, right? Any questions online? Kiran, are you okay? Kamiko, Kila, are you okay there? Wait, and Faraj is that? Oh yeah, Faraj, definitely. Faraj again, too. Oh, yeah, come on, boy, and do this one for me. Yeah, I get it. Try this, please. Try this one here. Right? And the rest I get to know the rules, feel free to look back at the rules, right? But I don't think you need, they should be similar to them. Try it quick. Online, if you get it, message QED. Yeah, yeah. Yeah, so next week I wanna have a class on the holiday. Can have a class. You want that time to wait up until then.
No, I just we don't. Yeah. It's around like.
No.
No.
What time is a good time? It will be online, it will be on just next Tuesday alone. Next week Wednesday, I'm gonna just to do my foot. When I get it, Thursday, I'll cover it. Huh? Thursday, you kind of have, so I don't want to do it and then come here and then. So we can go. Alright? So Tuesday, if we could have a class like, what time before them? What time will we wake up? 11? After 11? 1? 1 o'clock, guys?
Yeah.
Not more time, 1 to half 2. Yes? 1 to half 2 to work? Alright, I'm just gonna give you a mind, alright? So what, you gotta be waking by then, right? Online, that's okay? Just for next week alone, on the holiday Tuesday, I want to have a class instead of Friday, instead of Wednesday, right? Huh? Online, that could work, right? That is fun. Huh? Online. It could be in person for the one. Online could also do more, they might have a cookout room or something. Yeah, that is Wednesday. I do that in a Wednesday. No, not the same time, it's Tuesday at 1 o'clock. I'll message on the group to remind you. But I got you, QED, right, I'll get it for that Wednesday, the next one is a Tuesday. Got you right? I got you? Now you got? Online, I only have 2 QEDs so far. I have 1 QED. They're online, I need some more QEDs there, garage. QED, I need some. David, I see yours, nice. I got you? I got you? I'll go a little bit harder, right? Just 2 more. I got you? Left hand side. Again, you have to choose which side to use, right? So this is P and the negation of P or P and Q. P and the negation of P, that'll be false. False or anything is anything. That's okay? Let's go again. Yes, ma'am. Sorry, right in low next to it. No, that's my word. So this one is a distributor. Right? And then this one has a mixture table. P and the negation of P is false. And then false or anything. Right, come on the bottom to this one. Right, try this next one here. This one is about 1, 2, 3, maybe about 4 or 5 lines. Based on how you write. Yeah, so the first thing I use say Morgan's law, and then the reverse of it. The reverse of it. Okay, pick up a chair. Right, one line, catch the big action. Anybody got? Any more? Anybody got? No, back up. Yes. Right, take up. What's the first thing you will do? What's the first thing you will do? Okay, Morgan's law. So you will get negation of P Come on, right. What's it right now? Negation of Q. Right? And as I said, if you look at this, right? Isn't that the reverse? You're going from here to here, here to here. So if I wanted to go from here to here, what do I do? What do I write now? What do they both have in common? What they have in common? Ishana, what they have in common? What's your good? Yeah, they both have negation of P. And what symbol do I put here? Disjunction, conjunction. The or the and. Or, right? That's okay. Look at it. You're just going from here to here. Right? So they both have negation of P. They both have the or. And comes here. And negation of Q. Q. That's okay. Watch it back. This by this is this. This by this is this. And then the and in the middle. It's just the reverse. I see that about 9 times. What is this here? What's the negation of Q and Q? False or anything else? Anything. That's okay. 1, 2, 3, 4, 5. 1, 2, 3, 4 like that. You want it? If you want, no. I would say the counter is what you saw first. So you go ahead. You may not have seen this, but if you would have done it that way, then and then when you expand, then you have to expand the simplify each one individually. Yeah, it take a little while. And one of the rules you have to remember here, to go more than 4 or 5 lines, direction is supposed to long. Might end up by the answer, but it will take a little while. Right? But it should work. It work out. Okay. How many lines is it? But if you expand and went from here to here, without writing this, no. You, oh no, you have because if they allocated marks, they'll allocate one to the Morgan. Right? So that's the Morgans, then distributed, then it will right? Online, you also what happen here? How much QEDs are there online, any? One? What shall be? All right, let me just try one. One more. I'm gonna give you one more from this. Last one, right? Same principle, last one. Right? Real similar to the one I just gave you, right? Very similar to the one I just gave you. Make sure I write them correct. Go ahead, last one there. Online, let's hope we get a few more QEDs, right? Whereas, especially you. How will you get this one? Right? Isaiah, for the get you.
Yes, sir.
Can't get this one, right? Just follow the last one, right? Right? All I want to see QED, right? Right. Now you can see them coming in there. Yash. That's the sign name for the manager. Marquis. No, right? Huh? Yeah. Oh, wait, Dario, on this side, the English. What time is starting? Seven. Right, we were. What I give it? Yeah, or each one. Each one. Ishana Victoria. Maria Liver. Victoria. Anna. Samira. All right. All right, so last one. Everybody get it? Yeah? Good. Wait, Ishana, right? Right, so we have left hand side, first thing, expanders, negation of P. Oh, by the way, just suppose, right? Just suppose it end up and then here and here four. What do you do? Can you use this distributive law? No. Right? You'll have to use the distributive law a different way. This by this by this. The whole thing. You want to work like that. Right, so when you reach here, take out the negation of P or and you have Q and negation of Q. This is false, and the answer is negation of Q. That's okay. So if you see it, you have an idea what's right. Next, the next thing you're moving on to is the axiom. Do you remember that from Form 4 maths? Like additive identity and I can't remember from 4 maths. I'm not sure if them for you never see no like that. What you say? This is Form 5 maths, Form 4 maths. All it there. You remember this natural numbers and whole numbers and like yeah. And then what is closure? I remember this. What is closure and additive identity and then wait, I don't remember this. I remember it. All right. So huh? All right. But we're gonna go over all these rules here. All right. We're gonna go over all these rules. These are things that we do naturally in maths now, but there are rules, right? Like for example, additive identity. If you add 0 to x, what do you get? X. So 0 is an identity element, right? So those things we have been using them, right? All right, let's go back to pure maths. So that was a Form 5 summary, right? I'll just show you. That is supposed to have. Right, so and they are actually called axiom, right? Everything that you do in maths is built on rules, right? Although we use them, and with like example, 1 + 1 is built on a rule, right? And well, we have to know all of them, right? We have to know all the axioms. Right, so this smaller document here with the little notes, right? This document has no examples. It's just for you to look at just notes. Right, so for example, you're looking at the little definitions or those steps now to do something to be in here. Right, now that you're all in the group, I'm going to share it with you. All right. Right. Quickly, let's just see if we remember these things. Real numbers are made up of what? Right, the real numbers are made up of the rational and irrational numbers, right? What's an example of irrational number? Like third, right? Very good. Like third, right? And natural numbers and whole numbers. What's the difference? Right. Whole numbers 0, 1, 2, 3, all the way until all the whole numbers. Natural numbers don't have one. And one missing. David 90. Okay, what she said, added problem. Right? One more missing. We have whole, we have natural, after that is what? Huh? Negative values missing, right? Negative values missing. And we call all these what? Integers. Right? Call them integers. Okay? We call them integers, right? So if you see Z, it means integers. What does Z plus mean? Positive integers, right? And Z minus negative integers. Alright, just to make sure you know those letters. Alright, so you all may have been familiar with binary operations. For example, if I give you A star B is A multiplied by B. Huh? Go back down. Oh no, I don't know. That's in fact. Sorry about that. Right? Right? Integers is three, right? Sorry. Yes, irrational is Q hat. And Q union Q hat, that's the real number. All right, that's what they say it is member, right? Have to fix that, right? Right, so from form 1 or 2, we should remember something called a binary operation, right? There is something called a binary operation. For example, A star B, let's say A star B is A multiplied by P. That's a binary operation. So what is 1 star 2? 1 star 2 is 1 multiplied by 2, which is 2. You okay with that? Right. Now we have to learn some rules, right, about this binary operation. Right? The first rule that we're going to learn is what is closure. All right, let's take a minute and read it. See if that makes any sense. Take a little minute and read it, right? Closure. Actually, yes. Let's write it down. Write it down. Yes, Dario, you have to write it down now. Right? Take a little read of closure, right? And then I want to explain. So we need to know if an operation is closed. Right? They'll ask that. Is the operation closed? What does that mean? Right? Write it down and I want to explain. While you're writing, read. If you think you understand, you want to explain. Okay. Right, so take a look at that. So star is binary operation, right? And it's set to be closed, right? With respect to A, if A and B belong to A and A star B also belong to A. So here's what they say. Look at the example I have on top there, right? Let's say A belongs to Z. What's Z again? Hold on. All right, then down. A star B is A multiplied by B, right? Let's say A belongs to these elements, to this set Z. What is Z again? These integers, right? And let's say B belongs to integers. Then A star B is closed, right? If A star B is also from the set Z, right? So here's what you have to figure out. A is an integer, right? B is also an integer. So if I put an integer here and an integer here, and I multiply them, will I get back an integer? Yeah? Sure, all the time? Sure. Right? Very good. So it means that A star B is an integer as well. Right? So it means that this operation is closed. That's okay? So if when you perform the operation, you always get in integers, then it's closed. They all have to belong to the same set. A, B, and the function. All right? What do you all think about this here? What do you all think about A over B? Will A over B be closed? You just need one example for the counter example to disprove it. Can you think of one example that will disprove that? To make it not closed? And it's 1 over 3 over 2. A is 3 and B is 2. That is no longer an integer. Okay? That is now what? Rational. That's okay? So it means that A star B has values that are rational. Right? Therefore, in this example, it is not closed. All right? That's okay? Tomorrow. You sure? So all you need to disprove it is one counter example. That's all. All right? One counter example to disprove it. You okay with that? So that's the concept of closure. Right? All you have to do is just show that the function, sorry, the binary operation A star B belongs to the same set of values. You okay with that? Okay. Right, next one. Oh wait, sorry. Copy down, copy down the example there. Copy down the one on board then. A star B is equal to A on B. A is Z, B is Z, A star B doesn't belong to this. Kaban. Yeah. Kaban. Tomorrow, sorry. Huh? You sure? Trouble, Victoria? Any questions online? All right, so don't forget, right? Next week, class will be happy that one. It's 1.5 to. The phone was the problem. 1.5 to next Tuesday only, right? It will be online if you miss it. If you miss it, I'll be continuing from there and doing proofs like this. And I'll be doing direct proofs and I won't do PMI, but I'll say PMI. Right? Just try one more for online alone here. Not only for the one. Up to all. But that's the only one that I'll do a quick cool three. A star B. Just try this one here, please. Is this binary operation closed? Is this binary operation closed? What you know plus by this Z, right? What you know plus sign by the Z. Is it closed? Let's take out one example that I can disprove it, right? Yeah. Close. Close. Hope so. Online, what you all think? Closed or not? Right? Remember about plus sign there, right? So the plus sign indicates that what you all can see about A and B. A by B will always belong to positive C, right? That's okay. And then A by B minus A. That will always be what? Positive. Not say that? Because A, B will always be more than. Yeah. Yeah. What is upside down? A. I mean this. Yeah. Oh, here, right. It's two with respect to A, and for all. For all. Huh? For all, right? For all A and B the elements of it. Okay, so yes, so there is no counter example to disprove that. Right? A by B will always be more than A. So it means that AB minus A will always be a positive integer. Okay? So therefore, the answer is yes, it is true. That's okay? Yeah. Right, last two rules, commutative. Commutative simply means that A star B is the same as B star A. How do you say that? If A is, then you'll get 0, which is still a positive. Right? 0 will fall in positive or negative. Right? Are you okay with that? Right? Commutative. How do you show something commutative? You have to show that A star B is the same as B star A. So is our example here commutative? Right? Is this commutative? That is A star B, right? What is B star A? B star A will be B A minus B. Is it the same as this? No, not the same, right? Huh? It is? Yeah, but otherwise it wouldn't be the same. Right, so this here will not be the same as, it's not the same as that, therefore it's not commutative. Okay with that? So you're just switching the values around, right? We'll do partially over the next thing. And last thing, associative. Right, associative simply means that if I give you A star B star C, it means that if I work it out this way, or I work it out this way, I'll get the same one. All right, so associated, this has to do with how you prove them up. Okay with that? Right, I'll save the others the next. Right? Oh wait, no. I will show you distributive one time. Right, we'll do identity and inverse next week. Sorry. Yeah, I'll start. We'll check with it. Nobody here any group? I'm going to group. Probably just miss out one. People online how to get about them also. Right? Distributive is what we were talking about just now in algebra propositions. Right? I can expand this out. So it will become A star B triangle A star C. All right? That's a distributive. Next day, we will take a look at identity, right? And inverse, and then do some applications. Right? We have some proofs to do in mind. PMI. Up. Go back. Oh, you have to write it down. Oh. Yeah, David, don't worry, I'm the group. David, I'm not, I didn't know. All right, David, I didn't know.